So I'm going to talk, and because I think I said in the abstract, I gave a talk at ICA last summer about that the effects paradigm was dead and we needed a new way. And my critics said, well, that might be, but what's the new way? And of course, no one leaves a paradigm until they have a paradigm to go to. And I said, I don't know. But ever since then, I've been working on it. And I said to Joe, well, Joe, I'm going to be in Philadelphia, and I haven't got a paper yet, but I've got a talk. Do you have time to listen to it? And he arranged this. I really just meant to give it to him in his office. So, so you'll have to go wacky with me. So if not, and these are my notes, so I have to walk around to make sure I can see the screen too. So if I join you in the audience, that's why. So yeah, here we go. If not effects, what? So last year I said that the old paradigm, that mass communication, not necessarily interpersonal communication, had a paradigm, and that paradigm was the effects paradigm, and that I thought it was in crisis. And I said the evidence of that was the splintering of the field, increasing complexity of our theories, but with a decreasing or stagnant level of understanding. So it's harder to do this stuff, but we don't know any more than we used to. And I said that paradigms provide agreement on the fundamental nature of the field, so what we actually think it is, appropriate questions and methods, and that critical cultural studies is an example of splintering of the field because they no longer agree with us about the central definition of communication or the appropriate methods to use or what the questions are. They have a different nature in questions and methods, and I think they're actually their own discipline. And I don't think they're a scientific discipline. I think they're a humanistic discipline. And so that's one example of splintering. I think biological approaches to the field is another. So for example, this book came out recently, which had about 12 different biological approaches to studying communication. And I have a chapter in that book, and I would put myself in that splinter group. So Joe said to me, there he is. Joe, I found you on the internet. He said, well, Annie, what next? So here we go. This is what I think should come next. So the old fundamental nature of the field was that mass media or communication in general is an external force for change in otherwise stable humans and societies. So we had all kinds of balance theories and homeostatic theories, and the whole idea is we're all trying to stay the same, but communication comes in from outside and tries to change us. I'm going to argue that the new definition is that communication is an evolutionary development that promotes species and individual survival by increasing our adaptability to unstable environments. So the environment's not stable, we're not stable, and communication gives us a way to adapt quickly. So, and I'm going to argue that we're a biological system interacting with media systems that are embedded in an environmental system that's inside a social system that's inside a culture. So I'm taking a nested systems approach. I don't know what that last thing was. Oh, and everything, both the humans, the environment, and the systems we're embedded in are changing over time. Hey, it's bigger over there. So that makes it all even more interesting. So the old questions that used to be appropriate, what's the effect of this kind of communication or this kind of message or this kind of appeal or this medium or this use on this group of people in this place to achieve this goal? And the new question, I think, is how do humans and groups interact with one another in various environments through and with various media to promote their own goals and avoid harm? So it's not a question about effects, it's a question about patterns of interaction and being able to understand qualitatively different patterns of interaction. We have this sort of mid-range theorizing where we have little theories about little things and we keep making them more specific. And I think what we need is a general theory where humans, groups, media contents, and environments are not the things we're studying, they're variables in a theory of communication. So I want to take everything that are now things we think of as topics and make them variables in a theory of communication. I gave this talk at the other Annenberg, and they said, And after I did it, someone said, are you saying that communication should be the granddaddy social science field? And I said, yes, I am. So at least I'm reaching for the stars. So if not effects, what? New methods. We started out with primarily static surveys, one-shot surveys, a few longitudinal surveys. I'm saying we need dynamic measures. Nothing one-shot, everything over time, because what we're looking at is over-time interaction amongst at least 3 players at any given time. We used to rely a lot on self-report measures. I'm saying we need increasing use of covert measures, not necessarily psychophysiological. They could be observational, they could be behavioral, they could be all kinds of things. But people need to not know what we're doing. We need to not ask them, what do you think we're doing? Because I'm more interested in what they don't know they're doing. Some experiments we used to do in the old way, usually just to determine causality. So we'd say, we think this was causing this, so we'll do an experiment to see if in the short term it's a causal thing. Now I think we need continued experimental methods and probably survey methods, and we need to add in a lot of computational methods, because if we're going to look at nested systems interacting over time, we're going to have to get into some dynamic systems methodology. So, new questions. Here's where I want to go from here. So this is my working title, Human Media Interaction, and Evolved Brains Interacting in a Built World. So I'm going to go through these 7 topics, not quite in that order, and I'm going to do it fast. So put on your seatbelt. Okay. The most important thing about this approach is it's a human-first perspective. And what I mean by that, so Anne Boleyn, all she said was, what if the castle moved towards more peasant-centered inquiry? And we all know what happened. It wasn't a good thing. But nonetheless, I think we need to go to a human-centered perspective. And I don't mean do individual level research. If you're a systems researcher, if you do social systems, great. Groups, great. Interpersonal dyads, great. That's the system you want to understand. Cultural systems, great. And I don't mean media psychology. I'm not trying to just think about psychological explanations for effects. And I don't mean physiological measures. You never have to touch one. It's fine with me. But what I mean is that we need to start defining things from the only thing that's constant in a human communication system, which is the human. Everything else changes. So we have to define everything else in terms of the only thing that's static, which is the human. So I don't want to start with types of communication. All these things are going to use the same theory. Interpersonal, rhetoric, mass, mediated, computer-assisted, strategic. They're all going to have the same theory for me. I don't want to start with professions. The theory should be applicable to any goal. If your goal is persuasion, it should be applicable. If your goal is understanding, it should be applicable. If your goal is memory, it should be applicable. If your goal is to entertain, it should be applicable. I don't want to start with genres. Same theory ought to work whether you're telling a story or explaining how to do physics or trying to sell soap. I don't want to start with media because the medium is just a variable. It's the way you're trying to achieve your goal, to get your message across. So it's a variable. So instead, we need a definition of communication that's not media-centric, not discipline-centric, not any of those other things. It needs to be human-centric. So I started with a definition that already exists. This is John Sherry's definition, which I stole. And it is that communication is, see, we steal all the time. It's great. Communication is the scientific study of the processes by which brains interact. So brain-to-brain interaction is what I'm going to define as communication is, which means it's expressions, it's body language, it's any time my brain gets a message out to yours, even if you don't get it. Well, maybe you have to get it. You do have to get it. Okay, so that's a good start, but I want to add in a bunch of assumptions. So if this is the fundamental nature of the thing I'm studying is brains interacting with brains, then what are the assumptions that come with that? First, I'm going to get a bunch of assumptions from Darwin because I said the brains are evolved. So I have to take all the assumptions that come with evolution. So the big ones are, and you know them, so I'll go through them really fast. Species evolved through a process of natural selection, which allows long-term adaptation to occur. And remember, I'm arguing communication is about short-term adaptation. How do we change fast? And the time scale is really slow for evolution. And so what we've adapted to are invariants. That is, things that don't change over I think it says really thousands and thousands and thousands of years, probably millions of years. We just don't evolve to things that happen over 100 years or 10,000 years. It takes a long time. But there are lots of fast-moving things in the world, and we need to be able to adapt to them on the fly, and we especially need to be able to do that right now. So brains evolved to enable short-term adaptation. So I changed this definition. Now communication is the interaction of evolved brains. And also with evolution, we get this notion that brains are organs. And so, and that thinking is physiological, biological, chemical activity. It requires blood and oxygen and all kinds of support. That consciousness is an emergent property of the complex dynamic system that is the brain. And a lot of thinking is automatic. In other words, you can't stop it. All kinds of stuff happens in your brain that you have no control over. You can't stop it. It occurs without your conscious awareness, and it requires few or no cognitive resources. And it happens really fast and continuously. And this is the kind of stuff that is driving that is biasing all our interactions with the world. I think it says some, I made those things go blue, but we haven't time for that cute stuff. And most of what you're doing at any one time is being monitored and controlled by the embodied brain without your making it happen. So you move around, you talk, you take your body through space, you walk up and down, you negotiate difficult things. You are constantly doing stuff, and your brain is constantly making it happen. So moving, perceiving, selecting, acting without conscious awareness is adaptive. It's evolved, and it's common. Your cat does it too. You know, because if you had to spend all your time on the stuff you're not spending your time on, we'd never have time to think great thoughts and have a lot of fun. So yeah, these are all animals that go along doing their thing. And they also evolved the ability to interact. One of the things that really interests me is that animal communication is in biology, but human communication is a social science. But animals are social too, and they're hard to predict, and they kind of make rudimentary decisions, and yet they're biological. But we study human communication as if it had no biological origins. But I think it does, and I think they're important. So now we have communication as the interaction of evolved embodied brains. And now I'm going to add in my current favorite book, Supersizing the Mind, which by Andy Clark, and it's a book on embedded cognition. And the big argument in the book is that we use the world to think, that we didn't evolve in a room with no light and no things. We evolved in the world, and so we don't actually, as is usually taught in psychology and philosophy of the mind, spend a lot of our cognitive resources bringing the world into our head so we can manipulate it, because that would be very expensive. Instead, we leave it out there and we just coordinate our body with it. The only stuff we bother to put in our head is stuff that won't stay still in the environment for us to leave it there. So he argues you're always somewhere. Somewhere has invariance, like this floor isn't going to get up and start moving, and the walls aren't going to get up and start moving, and things aren't going to start happening, so I don't need to pay attention to them or encode them or make them part of my world. So they have general invariance. Also, gravity's not going to go away, and context-dependent variables. And because the brain evolved through interaction with the world, it makes sense to imagine that it uses the world to enable thinking. And so the argument is that thinking involves loops through the physical. So the act of writing something down is not just to remember it later. In writing it, you change it. You think about it. You make it a bigger thing. So this is an example, but I'm kind of slow. I'm not going to tell it to you, but sometime I will, if you like. So now we have communication as the interaction of embedded, evolved, embodied brains. So now I'm going to add Gibson. I don't know how many of you know Gibson's ecological perception theory of affordances. Some people do, some people don't. Well, that's James and Eleanor Gibson. And it's sometimes called the theory of affordances. And the argument is that the world is made up of 4 categories of things: substances, like air, light, and water; surfaces, grounds, walls, tops, anything; objects, which are movable things; and animals, dogs, cats, and humans. And an affordance is whatever the substance or the surface or the object or the animal can provide to you. at a given time in a given place. So right now, this floor is affording me the chance to walk. But if I wanted to get really tall, I could walk on the table because it affords that. And the air is affording me breathing, and this object is affording me changing my slides. But if I suddenly saw somebody rushing at me to attack me, I could also throw this at them. But I wouldn't usually think of this as a projectile. But as soon as I need it, it has the affordance of being a projectile. So affordances are in the object, not the perceiver. They're perceived directly and automatically embedded in space and time. So the affordance of an object changes depending on who sees it, when, where, and what they're trying to do. So the object owns all its affordances, but you only directly perceive the ones you need. So this is an automatic perception of what you need out of something. And I'm arguing it's a mechanism of embedded thinking. It's the way the world tells us what's available for us to do in a given place without us having any conscious thought. So in the theory of affordances, we have air, light, and water, and they afford function. And I'm going to argue that all communication between brains is mediated. We don't actually have straight brain-to-brain communication like in science fiction books, darn it. So air affords speech. You can hear me because there's air, and I'm making sound waves go through the air. And you can see me because there's light. If we make the light all of a sudden go dark and there's nothing else, you won't be able to see me anymore. And these are the original media of communication. They're the first media into which we had to encode messages to send out to other brains. Surfaces afford action, like walking, climbing. Objects afford behavior. You act with objects. And my favorite, animals afford social behavior. So we're going to take this animals afford social. So now we have our original media, and all communication is now mediated. And we're going to add in these animals. So what's the definition of an animal? Gibson says an animal has to have a closed body envelope. It has to have a defined shape. Oh, we went too far. Let's see, closed body envelope. It has to be able to change its external appearance, right, by moving or taking different postures, changing your expression, all kinds of ways we can change our external appearance. And it has to display self-generated behavior. In other words, it has to seem like it does stuff that you can't predict. So I'm going to take Gibson, combine him with Reeves and Nass, the media equation, who argues that people respond to media like real life and that people interact with the media as if they were people or social actors. And I'm going to say that's because media are an awful lot like animals. They have a closed body envelope. Most of them can change their appearance. Now, mind you, they're not doing it themselves, but they have a screen and different stuff can pop up on the screen. Even a book, when you turn the page, it has a new appearance, and sometimes it's a picture, and sometimes it's a thing. And if you can read the words, it's telling you stuff that is like behavior. It's behavior light, okay? And so I'm going to argue that the media that we've developed in many ways are brain-like creatures. So sometimes we communicate with another brain, hi, SK, and sometimes we communicate with someone through a brain-like creature or a medium, and sometimes we just communicate with a brain-like creature. We're not really particularly interested in whether there's other brains on the other side of it or not. So if you put it all together, Sherry, Darwin, Clark, Gibson, Reeves, and Lang, then I have this definition of communication. Communication is the interaction of some combination of embedded, evolved, embodied brains and brain-like creatures. And so for me, that's the fundamental nature of what we are studying. And see, we really do love our media. I like this one. So how do you like your new iPhone? Oh my God, I just love it. As a matter of fact, last weekend we flew to Las Vegas and got married. So human. It's human because it's brains interacting with brains and brain-like creatures. So this part is where I try to make the argument that everything is nested in everything else. And so whatever level you're at, you're constrained by the things below you and constraining the things above you. And there's interactions going up and down between the levels. And so I'll go through this pretty fast, but each system functions on its own as a system, but it also functions as part of the higher order system, which is functioning as part of a higher order of systems, and all of which are constraining one another. What's important about that is that at any given time, the combination of constraints defines the possible actions the system can take, because otherwise it would be chaotic. At times it is chaotic. Okay. So in the old media-centric theory, we had systems kind of like this, and we can still study those systems, but they no longer define exactly what we're doing. And these are the ones in the new ones. So we have the human biological nested system, which is the motivational system, nervous system, perceptual system, cognitive system, which is located in an environmental system, in a social system, in a cultural system. And as we think about systems, we have to think about questions like, what's the primary function of the system? To what things in the world does the system respond automatically? At least for biological systems, I think there's a corollary to that for larger systems, that there are certain responses which are essentially either built into the system or in some way reflexive, so they happen automatically. What's the time course of the system? Is it a system that changes over milliseconds, minutes, hours, days, years, decades? How is the system limited by those above and below it, and how do they interact? What are their channels of interaction? And how can human-centric things about the system be used to explain communication? Because humanness constrains all communication and social systems. Okay, so here's an example. Human perceptual systems. We can't be aware of everything in the environment all the time, but we have lots of systems that are involved in pulling out the important stuff from the environment at any given moment. And this is the process of biasing our senses towards goal achievement. So one of my big arguments, and here it is that in media, in mass communication especially, bias is a bad word. You know, we use it as that's a biased message, or we're going to see if they're biased or if they're objective, and that comes out of our journalism roots. But also we worry about slanted messages and framing. You're trying to get them to do this way and things like that. And the argument I want to make is we're always biased. We're biased by our own goals and our own needs and what we want at any given time and what we already know and our past experiences. And all those things are functioning to drive our perceptual systems so that in any given place, and now I'm going to sound like one of my friends in communication culture, we don't all see the same world. The difference between me and them is I think the same world's out there. We're just picking different parts out of it to see. And what's important is, what are the things we're all seeing? Because they're automatic. They're built into our biology. And what are the things related to our goals, and what are the things related to our experience that make our worlds different? Okay, so pause for a word from our sponsor. So one of the big things about developing brains, and since brains are the center of everything, is that they're just huge energy hogs. And one of the things humans really do is save energy, because the first 6 or 7 hominids that have developed before Homo sapiens sapiens died of starvation, because it's just hard. This thing on top of your head takes 500 calories a day if you're not thinking hard. So lots of things happen in the ways humans develop to try and save energy. And media are a great energy saver. You know, so a lot of the things that we think are bad about media, we're always talking about media like they're bad. And that's, I think, comes out of the effects paradigm. You're changing things, and change is always bad. You know, so, well, people are now fat because they use too many screen media, and they don't go out and play, or something like that. But actually, a lot of media, as we've invented better and better media that are returning to air and light, right? They're going back to air and light. When you watch TV, you're as close to air and light media as you can be. That's the medium you evolved to deal in. You don't no longer have words and type and symbols and codes between you and the communication. So a lot of media save our cognitive energy. They allow us, of course, access to physically distant things and physically distant places. And they use representations and symbols to increase informational and decrease the emotional load of messages. And I'm going to talk about that quite a bit later, because it's one of my favorite parts. So, and they create interfaces when they're well done, when media are well done, that use our embodied actions to make them work. So that's what I think we call in our field transparency, when the automatic response is the response that runs the machine. So these are just examples of evolutionary laziness. I mean, we will always take the easy way out. And I like this one too. People say, why are they always sending me email? Because it's too much work to do any of that other stuff. It's both physical work to get to office hours. It's informational work because suddenly you have to have a give and take. You're not in control. And it's emotional work because it might be scary to go there. So instead, you just send an email. Isn't that great? So processing media from an energy-saving point of view, cognitive capacity is limited. Conserving cognitive energy is also conserving capacity. And so we develop the ability to make things automatic, right? So you can automatize a task. It's easy to do. It takes, I don't know, what do they say, 10,000 hours to be an expert, and that's super automatic. But after, you know, a much shorter period of time, you can make something automatic. Things like driving your car no longer take any thought at all unless something becomes difficult. So we have this ability to make things automatic, which means as you become expert at something, then you automate all the things you need to do that thing, and then they become part of your automatic perceptual system that's letting you know when you can do the thing in which you're expert or when you see things that are related to it. And in communication, we tend to call that heuristic or biased processing. But it's just automated processing that's related to our experience. So what I do automatically is different from what you do automatically because of my experience and the things that I have automated in my existence. But we have a lot of things we do the same too. So back to our show. So we have these nested biological systems of humans. And bias is natural, automatic, evolved, adaptive things. And so and they tell us stuff. They have functions besides, we think about eyes and ears as seeing and hearing. But actually, functionally, what they're doing is telling us where and when things in the environment are in relationship to our bodies. We are always the center of our own world. And that's the embedded part. So everything comes from there. And your senses are telling you about where and when things are around you. And they respond automatically to certain visual things because they're built to do so. So like your visual system has specialized cells that respond to these kinds of things. Changes in light, edges, orientation, texture, motion, direction of motion, colors, binocular disparities. So media with visual components can be defined in the terms of which they have these things, in which they automatically activate those aspects of your perceptual system. Some do, some don't. Some do motion, some don't. Some do edges, some don't. Most do edges. There's also time courses, right? So everyone always says a picture is worth 1,000 words, and you can see, here's the picture, there's the description. But it's also true that if I could put this talk in a picture, it wouldn't take so long. You just get it. But instead, I have to have this very long verbal thread where you have to hold all this early stuff in mind as we go through, and I put it together more and more because that's just the way auditory processing is. At least verbal auditory processing. Symphonies are nice, and it is kind of all at once, but we don't do a lot of all at once audio processing. So media could be defined in terms of perceptual channels, in terms of the rate of information introduced in perceptual channels. They could be defined in terms of selection and attention systems. Do they drive automatic or demand controlled attention? So TV drives your automatic attention. The book requires that you want to. Okay. What types of content elicit automatic attention? So, gore, if it bleeds, it leads. Why? Because it's really hard to look away from things that are bleeding. They demand automatic attention. What features of a given media elicit automatic attention? What does this medium have that causes you to pay attention? Media could be defined in terms of motivational systems, which are a very basic part of our nested system, which single-celled animals have and non, and you have to look at good stuff and bad stuff. They'll query whether it's good, but it's at least interesting. And so we could define media in terms of their ability to elicit motivational activation, which in turn modulates cognition. So our human-centric definition of media, any medium, might be whether that we would define media in terms of whether they're one or two or three or four dynamic or not dynamic, but most of them are dynamic, streams of information which vary in relatedness of streams that are perceived by some set of perceptual systems encoded in various representational or symbolic forms, and that all the channels contain both form and structure and content, all of which can drive automatic biasing of your perceptual systems. So there's an example of how you might define television using a human-first perception definition. So many of our theories reflect this combination of energy. See, I'm not trying to get rid of the old theories. I'm reframing them because they're there. We know they're empirical results, right? But they reflect this combination of energy saving and integrated dynamic multi-system automatic processing, which evolved to respond to a real world that did not display animate behavior, right? So when things around us start displaying animate behavior that are not real, we're not going to respond to them as unreal automatically. That has to come later. So all of these three, ELM, cultivation, framing, priming, and agenda setting, are all based on fundamental automatic processes of the biological nested systems. ELM says, well, you're going to process automatically unless it's personally relevant. Then you're going to pay attention, right? Personal relevance is the thing that takes me from one kind of processing to a completely different kind of processing. So we have a qualitative state of, I'm just sitting here kind of not thinking very much, letting you take care of it, and now I'm really paying attention to what you're doing and thinking. And the thing that moved us from one type of interaction with the medium to the other was something about us. It was self-relevant. Sorry, I keep hitting that. But it's like having the band over there playing drums. Framing and priming also are clearly related to trying to set up a certain way of biasing the perceptual system so that you will see the message in a certain way, that you'll get a certain level of emotion going or a certain set of knowledge parameters active so that the way you perceive the message will be related to the things that are active. And the other two are based mostly on automatic frequency counting mechanisms, which are good to have because you want to remember which hill has a lot of food and which hill has a lot of danger. And so you kind of count stuff automatically. Okay, so in the new way, media are not biased and do not bias people. Instead, people perceive the world in a biased way. We all perceive our world in a biased way. And I already said this because I didn't realize this great slide was here, so we'll go right through it. Okay, so new questions in the new way should not be, does some type of medium, content, or production feature bias people in some particular way, but rather, how do the automatic unconscious aspects of humans in general, or of this human or group in particular, when you're targeting, interact with relevant human-centric aspects of the medium, so all those ways we can define media in terms of humans, to predictably, and the content of the message, to predictably bias the response. So how can we create the bias we want? In other words, how can we predict what bias will come out of what set of variables? And at all of these levels. So this is the stuff I was talking about. So if stuff is going to stay around in the world, right? I talked in the embedded, why would you bother? So one of the things I think if you want to say, hey, this is a new way to go, is you have to have risky predictions, right? That don't make sense in the old paradigm, but make sense in the new paradigm. So I'm working on these. So out of this notion, I would argue that this is an explanation for change blindness, which many of you have already heard about, yes? Which is that when you watch TV, and it can also happen in the world, if there's a structural feature of some sort, and you can change really big things, like the colors of the walls and what people are wearing and the stuff on the table when two people are having a conversation, and people watching the TV show or the movie don't see it. It's called change blindness. They miss big changes in what they're watching. The most famous change blindness study was also interpersonal, because they have a Confederate talking to a guy on the street, and he's asking for directions, and the person is giving him directions, and then two workmen come by with a door and walk between them, and the guy he's talking to ducks out, and another guy takes his place, and the new guy starts talking to him, and then about 70% of the people don't notice the person's changed. And the reason would be because we evolved in a world where people don't change. If you're talking to an animal, it stays there until it walks away, right? It doesn't just become another animal. So that would be an explanation for change blindness. But then we said, well, what if you, and one of our big arguments is that things that can change, like animals and objects to some extent, are the things that ought to be encoded, and things that aren't going to change, like the ground and the trees and the stuff around you, you shouldn't bother. So we made this hypothesis that fleeting things or short timers, things that can move around your environment, are going to be remembered better than stable things. And so we said, so if you're watching television, then the shorter something stays on the TV screen, the less amount of time it spends on the screen, the more likely you should be to remember it. And the longer it's on screen, we said the less likely you should be to remember it, which is pretty much the opposite of what you would make from a standard cognitive processing theory. And this is the study we just ran, and this is a mere 38 people. And of the fleeting things, the short things, they're remembering, I don't even know. I think this is D prime. So they have more sensitive memory for those, and then they do for the stable things 4 times better. I mean, it's a pretty good size effect. So that's one of my risky hypotheses that's working. Okay, so time. Without time, there's nothing at all. And because it's based on interaction, and interaction takes action, reaction, action, reaction, action, reaction. It's not all smashed into one place. And one of my big things is that interaction is a property of humans. No matter how interactive the media, if a human doesn't come up and start interacting with it, it isn't interactive. But you take a human, you put them in a room with nothing to interact, and they go crazy. We interact. We interact all the time. Okay? Now, usually in communication, mostly we do before and after, and during sometimes, but we just average over the whole thing. And I think we need to look at time in a lot more interesting and complex ways. So all of our nested systems have different time scales, and media messages have different time scales, and interactions with media have different time scales, and all of these time scales are influencing how we interact. Also, the synchronicity of media matters. So if I'm acting on one time scale and whatever I'm interacting with is on another time scale, that's going to mess up the interaction. So like when you have a phone call with somebody and it's being bounced off the satellite, are those not the most frustrating conversations? Even though you know cognitively that it's going up the satellite, you got to wait for the response to come back. You still end up thinking they're stupid. They think you're stupid. The interaction doesn't go well. It's not a good idea. So I'm skipping over some of this because I want to get on. So then space is really important too. And in old communication, I think it was the line between interpersonal and mediated, which I don't think matters because it's brains interacting with brains, and we'll do it any way we can. The context in which communication occurs, which does matter, but instead of studying it, we tend to control it in effects research. But space matters because the most important thing about media is we adapted to the real world. And anything media does that can't happen in the real world becomes very interesting. because those are the things that our automatic reactions will be wrong when they respond to them, right? And that's why we react to media like they're animals and like they're real and like they're there, because they trigger the reflexes of the real thing. And we never evolved to deal with things that weren't real. Yeah. I said that. Yeah, so this is my little story of media, but I want to get to the end, so, and I started late, so. But this was original air and light, right? So we had each other in the same place, and then we added some distance. We got smoke signals and drums and stuff, and then we learned to use representational systems like cave paintings, and so then we had messages we could share when we weren't actually there with non-colloquial, and then we learned to write in we had symbolic systems, and then we added animals, and we carried our symbolic and representational systems around, and then we got more substances, so we added in electricity in the electromagnetic spectrum, and so we got all these things, and all of those things gave us something we never had before, which was the stabilization of brain-to-brain interactions. Once we started writing it down or drawing it or making a recording of it, then we stabilized the ephemeral, because before that, all communication interaction was ephemeral. And we stabilized fantasy, and we stabilized the unreal. So now we have this world that's full of stable fantasy, but there's no way for our brains, our automatic brains, not our conscious brains, to tell up front without foreknowledge whether we're dealing with reality or fantasy, which makes media really interesting. So anyway, all of these media afford brain-to-brain interaction through and across space and time. Okay. Before the additions of media and air and light, all communication was synchronous, co-located with real animals in real places, but now they can occur anyway, and place, and where the place is automatically biases the interaction. Okay, symbols. Okay, so a symbol, the traditional definition, well, I say traditional like there's only one, but I acknowledge the giantness of the symbol area before and all the other areas I'm talking about in shorthand. But usually we say a symbol stands for something else. And so we have objects like my remote control. And then we have representations, which are things that resemble objects. Very nice resemblance too. And then we have symbols, which stand for the object. So it's a Logitech clicker. So these are the three levels of things that we might deal with in communication. But when you say that something stands for something else, it's not really human-centric, because this property of standing for seems to belong to the symbol. So the human-centric definition is that symbols and things are in the world, but brains throw together the symbol and the thing. Okay, so it isn't a symbol until it encounters the brain and is thrown together with an automatically elicited mental representation of the thing. And I stole this from Hofstadter, who said there are objects in the world, then there are passive symbols, which are signs outside the body, words, letters, icons, things. And then there are active symbols, which is the actual brain pattern that does not act in isolation. So what he means by that is objects fire perceptual neurons associated with themselves, and that causes you to see an internal representation of the object, right? So if I say white elephant, I know what happened in all your brains. You all saw a white elephant. Representations share some perceptual channels. So this is a picture of a lemon, so it shares a visual channel. If we really had the scratch and sniff sticker here, we could scratch it and it would share the smell perceptual channel. But they fire fewer sensory neurons than the object itself. They have fewer channels of information and less detail. Symbols, on the other hand, don't look and sound like the object at all, right? But when you see them, they fire a representation. The sensory neurons are what the word looks like. You see that. But they automatically, you can't stop it, fire an internal representation. And that's the act of a symbol system, is to automatically cause something else to become active in your brain. So many of the things that are fired off by the brain in response to a symbol are biologically real, and some are not. But the thing about symbols, if you think about them this way, is they allow us to treat objects as if they are not real. And treating things like they're not real reduces their biological significance and their emotional significance. So this is to remind me to tell you a story about this lady who is a psychologist, and this monkey is one of her subjects. And in this series of studies, she's trained apes to a pretty standard task where they come in, there's two of them, and they put objects on the table. And the ape who's in control points to the object he doesn't want, and it's given to the other ape. And they know the task perfectly well. And, put down 2 toys, points to the one it wants. It points to the one it doesn't want. That goes to the other ape, it gets the one it wants. And this works great until you take 2 bowls of food, one of which is very full and one of which is not very full, and you put them on the table, and the ape points to the full one, goes to the other ape, and the ape throws a fit. And you can do it over and over and over again, and the ape will continue to point to the full bowl. Now, these apes are very smart apes, so they also know some symbols, and one of the symbols they know is more and less. So you take the same bowls, you put tops on them, you put a symbol on one that says more and one that says less, and the ape points to less. The small bowl of food goes to the other ape, and the other ape is happy, and gets a big bowl of food. And this is what I mean by it reduces the biological and emotional significance of the things you're doing. And so our ability to deal in symbols has removed us, not from biological imperative, motivational reflex in some way, and also from reality in a very interesting way. So if objects are their affordances, and affordance exists in objects, then if you have the object, you have its affordance. If you have the representation, you have some visual channels, but you don't have all the affordances of an object. You might have some, if some of its affordances are visual. But symbols don't share any perceptual information. They're qualitatively different from the objects they stand for, and they don't share any direct affordances with the things that they do. So that word will not do any of those things. But what it will do is it will let you think about lemons. So thinking affords creative adaptation and saves energy. Whoa, what a great evolutionary thing. Now we can sit around and think about all the stuff we're going to do and figure out the best way to do it while basking in the sunshine. And then we can just go do one thing. And here's a really cool thing about symbols. They're linked to each other. Not only are they linked to their symbol is linked to its own representation, but those representations are linked to all other sorts of related things. And all that stuff is information. So symbols allow us to store information in organized ways. So we can learn stuff, think about stuff, and practice stuff in our heads. So I'm just going to say, if you think about symbols that way, then a lot of our theories like knowledge gap and theories about expertise and all that stuff, suddenly you think about them a slightly different way, and you get some kind of interesting hypotheses that are counter to the current things, but that actually kind of work out. I'm still working on a good example of those. But the big idea is the more expert you are, the more symbolic information you have about something. It says I should think about stopping soon. From when I started, not from when you said I'd stop. But this is the last bit. Do you want me to stop before it? No. Okay. Good. So symbols, because you can call up all this information, it's easier for you to bring in new information. So the ability of experts or of people who know a lot about something to learn more from the same presentation is then explained by that ability, because they can take in more information because their symbolic network is already more advanced. So I started with it's all a dynamic system, and I'm going to end here, and this is the hardest part, and I think the part that is the most difficult, but it still has to come at the end. So when I gave this talk at ICA last year, who was it who said that if you thought about things going down the hill, they would jump and all this, and that if you had to have water pipes and all this, and I said I wanted hydrology. I don't know if you remember that. It's a really, really complex thing. We're talking about a body and a mind in a place with a bunch of media, in a social system, in a culture, and it's a huge complex system, and that's really hard to understand. So it's really complex. And so behavioral dynamic systems theory is the belief that much of our behavior is self-organized through interaction between our bodies and the environment. So the idea is that a great deal of our actions are not thoughtful. Even things we think are thoughtful are actually being carried out by body world computations. So like when I want to go to catch a ball, I'm not computing the trajectory of the ball. A lot of models think you are, but there's actually really good research now that shows you're not. But I'm not computing that and doing this and all that. Rather, I'm using my perceptual system to lock the ball in place and moving my body until they're going to intersect. And it's a body-mind perceptual system interaction that allows the ball catching. If I think about it, it actually gets in the way. That's why dogs catch frisbees better than people do. And it happens a lot of it without consciousness. And here's the big thing, no executive controller. You can think all you want about controlling your behavior, but in the end, most of us fail a whole lot to control our behavior because a lot of it is self-organized and we're doing it before we even thought about doing it. So self-organizing systems have two characteristics. They have a lot of, their elements interact in nonlinear ways, which is sometimes just called complexity, which means that they might change, that a change in one might cause a change in the other. Now, most of our theories are linear. If I change this in this media thing, then I'm going to get this effect in this person. Maybe curvilinear occasionally, but mostly we expect kind of a one-to-one change, and we expect it to be a consistent change. But in nonlinear systems, sometimes you might get that, but sometimes you might get no change at all. Same thing might have no effect at all. And sometimes you might have a completely qualitatively different kind of effect. But it's not because there isn't an effect. It's not because the thing you're interested in isn't changing behavior. It's just that it can change behavior in multiple ways, and you have to have control over many parts of the system to know which way it's going to change behavior. So one of the things that's interesting about dynamic systems is they're open to energy. They are not homeostatic. So as I said before, a lot of our theories are about stasis and homeostasis, but humans are not closed systems. We're open systems, and we have to take in energy to maintain any kind of similarity. And dynamic systems are characterized by energy, having a range of energy levels, needing energy in and energy out. So, and because of that, a system can be stable way far from any kind of thermodynamic equilibrium. So we can have a high arousal, stable system and a low arousal stable place, and they're qualitatively different places. And the interesting question is, how can media move me from one to the other? That's an interesting question. How can it move me back? So degrees of freedom are the number of things that can vary in a system, and in all of the parts of a system. So in just my small system of humans, mediated messages in a context, then these are the things that can vary about humans, those are the things that can vary about the environment, those things can vary about media, and so there's a lot of complexity in this system. And all the possible things added up that could vary in all those systems are your degrees of freedom, and it's called your state space. It's all the possible states that the system could assume, okay? And sometimes you get various kinds of patterns of behavior out of the state space. And the ones that are interesting are these. So cooperative modes result in emergent patterns. So this is a stable pattern of behavior arising from a more chaotic condition. Okay? And these things arise as the result of an order parameter. And an order parameter is the slave boss. This is a collective group of elements in the system which reduce the degrees of freedom for other elements of the system and result in the emergent pattern, which is a mathematical and complex way of saying that the control parameter slaves a bunch of other things to it. It forces automatic reactions out of a bunch of other systems, which cause elements of the system to all do the same thing. And so you get an organized pattern of behavior coming out. And these things are called attractor states. And we spend a lot of time in attractor states. Okay, so for example, did you guys all notice that door opening just a minute ago? Yeah, and there were a lot of looks that way and everything. That was actually, briefly, we had an emergent pattern of many eyes going over to the door. And I worked hard not to look over there because the door opened, because that was an order parameter. Everybody had a perceptual response to it, an attention response. They checked to make sure it wasn't some guy with a submachine gun coming in to wipe us all out. And then they went back to listening to me. So briefly, we saw an emergent pattern of behavior where all heads turned that way. It was very interesting. And it came right at a good moment. So nested systems can be closely coupled. And so a constraint in one system can act as an order parameter on another system. And the human's made up of nested systems. So just within humans, because that's what I know best, but not because things about humans aren't going to slave social systems or slave dyads or slave group dynamics, and things about groups aren't going to slave the higher order system. But because I know about this, they all respond on different time frames to the same stimuli. And sometimes that looks like an emergent pattern of behavior. And it's one that you could predict would happen for most people most of the time. So I think there's an example here. Yeah, you're reading a book in your room. You hear a scream, which is the fastest thing to respond is your perceptual system. Your aversive system then activates, and you have a negative emotional response. You start, an attention response comes up, and you start looking for the behavior danger, which is cognitive and behavioral. You realize your roommate's watching a movie on TV, and the scream was on TV, and you feel foolish because your emotional system is the last guy in. So most people would have something like that would happen, and it would be changed by the context. If it was really dark and the wind was howling and your book was scary, that scream would have a way bigger effect than if you were reading your mathematics text and it was kind of loud and the sunlight was up. So there would be differences, but the basic pattern of automatic responses would be the same. So they're closely coupled. They're slave to the order parameter, which in this case was a scream, which is a motivationally relevant thing. So everybody who's evolved is going to respond to it. And that's an emergent pattern. Now, the other kind of parameter you get, so you get these attractive states and attractor states. An interesting question for us now is, what kind of attractor states do we get with what kind of media, with what kinds of groups, and what kinds of places? And how do we bring those about? Because some of them are good and some of them are less good. Okay. Now, I'm going to go on. Yeah, so the only other thing is this energy thing. A stable attractor state is hard to move out of. So like, what is that? What is that? Attention entropy. The tendency that when you're watching TV, you look, the longer you look, the more likely you are to look, and then you look away. It has a great name. I forget the name of it. It's some theory. But anyway, watching TV is a pretty stable attractor state, actually, which is why it's hard to look when there's one on in the room. You're always coming back and looking at it. It actually takes effort to pull yourself out of it sometimes, which is one of the reasons why I think people watch so much TV. Unstable states are a lot harder to maintain. So like really intense concentration is hard to get going. And when you get it going, it's really great. But when it goes, you're tired because it's a high energy state and it's tough to maintain. So it takes energy to shift out of stable attractor states, and it takes energy to stay in unstable attractor states. So you have to consider that when you want people to do something hard, you are moving them to an unstable attractor state. When you want them to keep doing reinforcement, the big effect of communication, when you want them to keep doing what they're doing, you're putting them in a stable attractor state, and that's much easier to do. Okay. Yeah, we said that. And so emotion is interesting too, because a lot of the time we go around feeling pretty neutral because it's pretty low energy and it's pretty stable. Kind of happy and kind of sad are too, but those moments of pure joy and really pure horror or grief don't last so long, and that's probably good, but they're high energy states. Okay, so the other kind of parameter we have in dynamic systems is control parameters, and this one is really interesting to us, I think, in media, because there are things that come in from outside and disturb the system. So a control parameter is from within the system, and it slaves the system. But the control parameter may be from an element of the system, but it actually moves the system from one emergent pattern to another, from one possible attractor state to another possible attractor state. So like in horses, this is an example. They give a lot, horses walk, they trot, they canter, they gallop. They don't do anything in between. So They walk, and then if you want them to go faster than they can walk, bam, they're trotting. And if you want them to go faster than that, so they're qualitatively different gaits, and the control parameter is speed. So they hit a certain speed and they shift gaits. They hit the next speed, they shift gaits. And they're organized, they're self-organized by the biology of the horse. The horse doesn't decide to do it, but the speed shifts the gait. So the interesting thing in media, one of the interesting things is what are the order parameters that move us through attractor states and interacting with media. So a linear continuous change in a control parameter, like speed in the horse's gait, moves the system from a chaotic state to an attractor state and then on to other qualitatively different attractor states. Here's an example, and this is the last thing. Oh, no, this might, well, oh, yeah, but this is an example. So automatic processing is easy. Attractor state, stable, low energy. Controlled processing is hard, higher energy. So what moves us from automatic, heuristic, peripheral processing to controlled central processing? Well, we know self-relevance, is it right? So in a sense, ELM is just telling us, hey, we have these two states, attractor states of the cognitive system interacting with the message, and one way to move from one attractor state to the other is the degree of self-relevance. So so if we're going to theorize dynamically about brain-to-brain-like interactions in a place over time, then we're going to have to learn about these order parameters and how they slave the systems, and then what the control parameters are that move us through things. So I'm just going to go through all this because it's too many words and we're tired, to this example. So here we are playing a racing game, right? So has everyone played a racing game with somebody? Now, when you play a racing game, the game is the order parameter, okay? And the game is slaving your perceptual system because in order to play the game, you must perceive what's happening on the screen and respond to it. It's slaving your sensory motor system because you have to use the controls to do the things to stay on the thing. It's slaving your motivational system because it's activating your repetitive system and your aversive system because you're trying to avoid harm and succeed and win in the game. So 3 of your systems are now slave to what's happening on the screen. And this is going to interact with things about you, the individual. So your skill level with the game, which will affect how your sensory motor system works and how your perceptual system picks important things out of the game. It's a slaved system, but if yours is really skilled and mine is really unskilled, they're going to respond a little bit differently. And the difficulty of the game. So how hard it is, whether it's at a low level or a high level of difficulty. And when you put those together with the structural features of the game, it's going to determine how many available resources or how much brain power you have to apply to this task, okay? So one of the control parameters of how well you do at the game is your available resources. Okay, if you've got a lot of available resources, you should play the game really well. If you don't, if it's taking everything you've got just to see the game and try and work the controls, then you're not going to do the game very well. Okay, so then task performance, how well you do, is also important to the game because if you're doing well, then you feel good, and that makes you want to play more, and it makes you happy, and so that's a motivational response. And if you don't play well and you're doing badly, then you may start to feel aversive, and you may start to avoid the game and not want to play. So task performance is feeding back into your system to influence your motivational activation. Okay. And so motivational activation is another control parameter here. So we have 2 control parameters. That means things that can move us through attractor states. So consider we have the highly skilled player moving through levels of difficulty. At easy levels, he has plenty of available resources. Task performance is good, feels easy, might even experience as boredom. In other words, he's really not trying. It's not even satisfying to win this level, so he might be bored. At moderate levels, still has available resources. Task performance is still good. Feels challenged, so upping the appetitive activation might be experienced as flow. At difficult levels, insufficient resources, task performance is dropping, feel out of control. You might get frustrated or angry. So the level of available resources combined with motivational activation is moving the player from boredom, which is an attractor state, to flow, which is an unstable and hard to maintain attractor state, because it is, as they say, the edge of performance and ability. So that means where you just have enough available resources, but anything more and you're going to fall over the edge into frustration and anger and failure. For the inexperienced player, the same game, the same situation, the same setting, but now the control parameters are going to act in a different way. You're going to start out with frustration because task performance is going to be bad and you don't have resources. But if you keep playing, because they make you, you should get to challenge, and then you might hit flow, and then you might go back to frustration when you start losing again. And it will be different if it's in the dark or there are other people in the room or you're playing against a computer or other people and the time of day. And we have to learn how all that stuff would interact with the basic slaving of the system to the game. And I think you can do this kind of thing at all levels if you can figure out what the parameters are and what's interacting and what's constraining that. And one of my things I've been thinking about to try and do that is that I think a lot of cultural and social norms are about not acting in an evolved way. And that social systems and cultures, to some extent, got us not to do these smart things. Instead of running away, we have to be courageous. And instead of taking more food from me, we share. And so a lot of interactions between the evolved animal and the social system are anti-evolutionary. They're not automatic. They require a lot of training and other things, and they can still be overwhelmed by automatic responses in given contexts and things.